going to talk a little bit about fish and how they are adapted to different environments. So we're going to take some fish notes. We're going to begin by talking about a marine fish. Marine is a word that is referring to a saltwater fish, which could also be called an ocean fish, and that's in contrast to a freshwater fish. So we're going to draw a little picture of a marine fish and talk about what's going on in terms of osmosis. So I'll draw a nice picture of a fish. No, that's not so good. Let's see if you can draw a better picture than that. How about that? A little marine fish action here. Got a nice shark. So let's look at the shark situation. So the shark, in this example, we've got salt water here. The water itself is hypertonic when compared to the fish. So the fish itself is hypotonic. So just draw your cool version of a fish, which could look something cool like mine. You know, you might have a fish that looks, you know, like that maybe. That's pretty good for me. No, not so good. Maybe yours should look like that. Anyway, the important part is that the fish is hypotonic compared to the water, which is hypertonic. Now we've learned water always moves to the hypertonic thing. And so these cells have a membrane on it. The water is going to move. Nature wants everything to be the same concentration on both sides of that membrane. So water is going to leave the cells of the organism here, the lovely shark. It's constantly going to have water leaving its cells. So it has adapted strategies in order to be able to survive all that water leaving its cells, because water is going towards the hypertonic thing. So once again, the water is hypertonic. The fish itself is hypotonic. Salt water has a very high concentration of salt compared to the fish's cells. That's why it's hypertonic. So a marine fish, just kind of doctor this picture up a little bit, like the one we've got there. A marine fish is constantly losing water out of its cells. So we'll write that. Constantly losing water through osmosis. So water is leaving the cells to go into the ocean water, the salt water. Because of that, so these are adaptations. We'll just write these below. You can put them wherever you want. So these are some adaptations that marine fishes have. They drink lots of water. So drink lots of water. What else do? They get rid of salt through special cells. Because they're drinking so much water. Through special cells. And they excrete a small volume of concentrated urine. So they drink lots of water, they get rid of salt through specialized cells, and they excrete a small volume of concentrated urine. Now, in contrast, we could look at a freshwater fish. Freshwater fish. Like a largemouth bass. Whoa, that's not right. No, that's not a largemouth bass. There we go. That's a largemouth bass. So you could draw that, do the best you can. Freshwater fish. This is a bass. Let's see, so I can draw this fish here and kind of got some nice little dorsal fins there and kind of come back around. Wow, that's a lot easier to draw when put a little eye in there. Pretty good. Look at me. Alright, so here we go. Now the freshwater fish has a kind of a different situation where the freshwater fish is hypertonic compared to the water. So this freshwater fish is hypertonic. The fish itself is more concentrated than the water that it's sitting in, which is freshwater, like Detroit Lake. So the water is hypotonic. So in a freshwater environment like Mill Creek or Willamette River or any freshwater river, the fish themselves will be hypertonic compared to the water. So water always moves to the hypertonic thing. So what's going to happen to the fish's cells? Should tell pretty quick that the fish is going to be filling up with water. So it needs to have some adaptations to be able to survive with that increased osmotic pressure as water is flooding into its cells in order to balance out the concentrations. Because the water here is hypotonic, the fish's cells are hypertonic compared to that, so to balance that out, water is going in through the membrane of the fish's cells. And so the fish needs a way to be able to deal with that. So the situation with a freshwater fish is that they, I'm going to change my pen color here, freshwater fish cells gain water through osmosis. As you can see in the picture we just drew, the fish's cells are hypertonic compared to the surrounding environment, so the fish is constantly going to be gaining water. Its cells are going to have water coming into it. So their adaptations are as follows. Adaptations. Their adaptations are they do not drink. Their cells absorb salt. I'll just write cells absorb salt. And they excrete a large volume of dilute. It means not very concentrated. Urine. Nice. Okay, so those are some of their adaptations. They developed adaptations in order to be able to survive the fact that their cells are continually gaining water through osmosis. So a couple things I want you to think about. First of all, let's say we've got Mean Kid running around. Mean Kid goes and grabs, like a halibut or some other kind of fish that you would find in salt water. Drops it into Detroit Lake. Or whatever else you want to call it, San Am River or Mill Creek. Maybe dumps it into wherever you want to. What's going to happen to that halibut and why? Another thing to consider, let's say you are stranded on a desert island. It's probably all not what it's cracked up to be, but let's just say that you are. What's going to happen to you when you decide you're thirsty and you want to drink some salt water? What's going to happen to you if you drink salt water? Explain to me why.